Good day to you all. My name is Mary Claire Elizabeth Gamao, coming from the Group 9, here to present our assigned topic, which is the multiple bonds. But first, what is chemical bonding? A chemical bond is the association of atoms or ions to form molecules, crystals, and other structures. The bond may result from the electrostatic force between oppositely charged ions, as in ionic bonds, or through the share of electrons, as in covalent bonds, or some combinations of these effects. Chemical bonds are described as having different strengths. There are strong bonds or primary bonds, such as covalent, ionic, and metallic bonds, and weak bonds or secondary bonds, such as the dipole-dipole interactions, the London dispersion force, and hydrogen bonding.
Before we talk about the types of chemical bonding, we will talk about what is inside a chemical bonding. The first is electron shells. Remember that every atom has a certain number of electrons which orbit the nucleus in the electron cloud. These electrons orbit in different energy levels, which are known as electron shells. The first shell can house 2 electrons, and it must be full before any electrons can move to the next shells, which can house 8 electrons each. The next is Lewis dot diagram, or the Lewis dot structure. In chemical reactions, the electrons in the outermost shell are the most important. We can represent elements using the Lewis dot diagrams, which visually emphasize those electrons over the others. Is valence electrons. The electrons in the outermost shell of an atom are known as valence electrons. In the Lewis dot diagram to the left, you can see the beryllium has 2 valence electrons. And the last one is the octet rule. Partially filled electron shells are unstable, so all atoms want to fill their electron shells completely. Since most shells can hold 8 electrons, this phenomenon is known as the octet rule. Atoms fulfill the octet rule by forming bonds with other atoms.
Ionic bonding. Ionic bonding is a type of electrostatic interaction between atoms that have a large electronegativity difference. There is no precise value that distinguishes ionic from covalent bonding. But an electronegativity difference of over 1.7 is likely to be ionic, while a difference of less than 1.7 is likely to be covalent. Ionic bonding leads to separate positive and negative ions. An example for ionic bonds would be sodium sharing its valence electron with chlorine. Sodium has 1 valence electron and chlorine has 7. Sodium can become stable or achieve the octet rule by losing its single valence electron and dropping down to the previous and complete energy shell. Whereas, chlorine can become stable by gaining 1 more electron and filling its outermost shell. These atoms can form an ionic bond in which chlorine steals sodium's single valence electron, creating stability for both atoms. So here we can see that these two elements are somewhat assisting each other in order to create balance, or what is called as the octet rule.
Covalent bonds. Covalent bonding is a common type of bonding in which 2 or more atoms share valence electrons, more or less equally. The simplest and most common type is a single bond, in which 2 atoms share 2 electrons. Other types include the double bond, the triple bond, 1 and 3 electron bond, 3 center 2 electron bond, and 3 center 4 electron bond. The example of a covalent bond is chlorine. Chlorine has 7 valence electrons and therefore needs 1 more in order to fill its octet. In the absence of any other element, chlorine atoms can bond with other chlorine atoms. Both atoms will share 1 electron, thereby completing their electron shells.
Now let us move on to metallic bonds. In metallic bonding, bonding electrons are delocalized over a lattice of atoms. By contrast, in ionic compounds, the location of the binding electrons and their charges are static. The free movement or delocalization of bonding electrons leads to the classical metallic properties such as luster, electrical and thermal conductivity, ductility, and high tensile strength. A metallic bond example would be copper atoms are held together by metallic bonds. In a piece of copper metal, each atom releases some of its outer or valence electrons. These electrons move freely throughout the metal, forming a sea of electrons that surround the positive copper ion. Hence, white copper is often seen as reflective or shiny at different angles.
We will talk about the key scientists that were involved. The first is Gilbert and Lewis. In 1916, Lewis proposed that atoms could form bonds by sharing a pair of electrons, which became the foundation for understanding covalent bonds. His work also introduced the concept of octet rule. The next is Irving Langmuir. In 1919, Langmuir refined Lewis' model, coining the term covalent bond and further developing the rules for how atoms share electrons to form compounds. And the next one is Linus Pauling. Pauling built upon the work of Lewis and others, most notably in his 1939 book, The Nature of the Chemical Bond. He introduced key concepts like orbital hybridization and resonance, which provided a more sophisticated explanation for the unique properties of molecules with multiple bonds. There were other contributors too. Several other scientists helped apply and extend these theories in specific fields. For organic chemistry, there are Arthur Lapworth, Robert Robinson, Thomas Lowry, and Christopher Ingold were influential, while Maurice Huggins and Neville Sidgwick promoted the model in coordination chemistry.